chain rule might be reading in Labor's notation as the following way. If a variable z depends on the variable y, which itself depends on the variable x, so that y and z are therefore dependent variables, then z, via the intermediate variable of y, depends on x as well. The chain rule then states dz over dx equals dz over dy multiplied by dy over dx.
So now I will show you the proof of the chain rule. The proof of the chain rule can be done in many different ways, but I decided to show you a fairly fast proof of the chain rule as we don't have much time in the video. So I will show an example, and in the example, if both f and g can be differentiated, we can say that the derivative of f of g of x at point x equals a can be seen by doing. Now for the example, as we can see, the limit of x tending to a of f of g of x minus f of g of a over x minus a is equal to the limit of x tending to a of f of g of x minus f of g of a over g of x minus g of a times gx minus ga over x minus a, and this will equal to f dash of g of a.
To better understand the chain rule, take the following formula. Consider 5 times the bracket cubed to be the outside function and the x cubed plus 7 to be the inside function. Replace the inside function by something, which we'll apply to something else. When calculating the derivative, calculate the derivative of the outside function while maintaining the inside function untouched with a something, and multiply that by the inside function, which in this case has been replaced by the word something. Now plug in back the values of the inside function, or x cubed plus 7 in this example, and do all the calculations. This will give a final result of 45x squared, open bracket, x cubed plus 7, close bracket, squared.
Let's do an exercise in order to see how the chain rule is really working. Let's consider the function w, which is equal to xy plus yz plus xz, function x, which is equal to 3u plus 2v, function y, which is equal to 3u minus 2v, and function z, which is equal to uv. Now, let's evaluate partial derivative of w over partial derivative of u with the chain rule, and at the point uv equals 1/3 2. The chain rule for a function of two independent variables with three intermediate variables is this one. Now, let's calculate all of these elements. Partial derivative of w over partial derivative of x equals y plus z. Partial derivative of x over partial derivative of u equals 3. Partial derivative of w over partial derivative of y equals x plus z. Partial derivative of y over partial derivative of u equals 3. Partial derivative of w over partial derivative of z equals x plus y, and partial derivative of z over partial derivative of u equals v. Now that we have calculated all of those, let's replace them into the chain rule we had at the beginning. So it gives y plus z times 3 plus x plus z times 3 plus x plus y times v. So now we are going to replace the x, the y, and the z by the functions we had at the beginning of the exercise. After this, we are just going to simplificate all the function. So it gives partial derivative of w over partial derivative of u equals 9u minus 6v plus 3uv plus 9u plus 6v plus 3uv plus 6uv. So we take off the 6v, then we can see we have 18u, and we have also 12uv. We can see that this gives us, by simplifying, 6u times 3 plus 2v, and we're going to replace u and v at the coordinates 1/3, 2. After replacing u and v by 1/3 and 2, and simplifying, we finally find a result which is 14. You now know how to use the chain rule.